Next, we will discuss the concept of a test statistic and what constitutes an evidence against a null hypothesis. In the statistical hypothesis testing, we will treat the null hypothesis as the assumed status quo. The goal of the testing procedure is to evaluate the strength of any evidence against the null hypothesis. We will not reject the null hypothesis unless the evidence strongly suggests the alternative hypothesis. In other words, we are not going to change the status quo unless the evidence is beyond a reasonable doubt. One may think of it as the presumption of the status quo principle, as an equivalent of the presumption of innocence principle in a justice system. Next, we need to clarify what constitutes an evidence and what evidence is beyond a reasonable doubt. Whether we have an evidence or not depends on the inequality in the alternative hypothesis and a particular observation of a sample statistic. Consider the following example in which the null hypothesis assumes that the height is 170 centimeters, and we're going to evaluate whether a particular observation is an evidence or not for different alternative hypotheses. If the average height of a sample is less than 170, then it is interpreted as an evidence against the null hypothesis in left-tail, two-tail, but not the right-tail test. Similarly, if the average height of a sample is greater than 170, then it is interpreted as an evidence against the null hypothesis in two-tail, right-tail, but not the left-tail test. Finally, if the average height of a sample is exactly 170, then it can be interpreted as an evidence against the null hypothesis as it literally confirms it. Next, we will introduce some vocabulary that will help us to determine whether we have an evidence or not. A significance level is the maximum tolerated probability of type 1. Usually, the significance level is determined from the context of the problem. The most common is 5%. But it can be brought up to 10% or down to 1%. The smaller the significance level, the stricter the test is. What considered a strong evidence under 5% significance level may not be such at 1% significance level. A test statistic is a value that measures how far a particular observation is away from what it is expected to be according to the null hypothesis. The way we compute it will vary for different procedures. When z-distribution is involved, the test statistic is simply the z-score of a sample statistic. When other distributions are involved, such as t, chi-square, or f, it will be analogous to the z-score, but it will not be called so. Note that each sample has a test statistic value that measures the strength of it as an evidence. So how exactly a test statistic can help us to determine whether we have an evidence or not? The observations that are smaller than expected will have smaller test statistic value than the observations that are larger than expected. So a small test statistic is an evidence that the population parameter is smaller than assumed in the null hypothesis. Similarly, a large test statistic is an evidence that the population parameter is larger than assumed in the null hypothesis. For example, in case when a z-score is used as the test statistic, we know that the average is 0, so negative test statistic means small, and a positive test statistic means large. The intuition is similar when a student t-distribution is involved, but for other distributions such as chi-square and f, the definitions of small and large are not so intuitive. Now that we know what observations constitute an evidence against the null hypothesis, we need to decide what a strong evidence is. In other words, at which point the test statistic is far enough from expected for us to reject the null hypothesis. This is when alpha, the significance level, comes to play.